So now let's find the exact value of a trigonometric expression using identities. So I have cotangent of 40 degrees times cosecant of 40 degrees over secant of 40 degrees. Remember that cotangent is cosine over sine minus cosecant, which is 1 over sine of theta, which is 40 degrees in this case, over secant, which is 1 over cosine of 40 degrees. Well, that means that cosine of 40 degrees over sine of 40 degrees minus 1 over sine of 40 degrees times cosine of 40 degrees over 1, right? We've got a complex fraction here. That gives me the cosine of 40 degrees, this is supposed to be a minus, cosine of 40 degrees over sine of 40 degrees minus cosine of 40 degrees over sine of 40 degrees. That's just going to give us 0. Let's work through another example using trig identities. So I have 1 over cosecant squared of pi over 16 plus cosecant squared of pi over 16. We can rewrite cosecant as 1 over sine. So I have this is 1 over sine squared of pi over 16 under 1, right? Plus cosine squared of pi over 16. Well, I can simplify this to be 1 divided by 1 over sine squared of pi over theta. That's just going to be sine squared of pi 16 plus cosine squared of pi 16. And I know from trig identities that the cosine squared of any theta plus cosine squared of theta is 1. So the answer to this is 1. So given that sine of theta is 1/3 and cosine of theta is less than 0, I want to find the exact value of each of the remaining 5 trigonometric functions. Now first we need to determine, based on the fact that sine of theta is positive and cosine of theta is negative, right, less than 0, what quadrant are we in? So what quadrant is cosine negative and sine positive? Well, that's going to be this quadrant right here where I've got x is negative and y is positive. So my angle theta unknown is going to lie in quadrant 2. We also don't know that we are on the unit circle definitively, right? So let's let sine of theta, so I'm going to have x squared plus y squared equals, instead of 1, let's have it equal 3. So then I have x squared plus 1 squared equals 3. I got that from my numerator, right? This is one way we can approach to solving this. Says I have y over radius. Remember that sine of theta, if we don't know the radius of our circle, is y over radius. Cosine of theta is x over radius. Tangent of theta is y over x, it doesn't change. Cosecant of theta is r over y. Secant of theta is r over x, and cotangent doesn't change. So that's why sine of theta, which is y over r, would be y is 1 and r is 3. So then we've got 3 squared. So I have x squared plus 1 squared equals 9. So I have x squared equals 8. So I have x equals the square root of 8, which would be 2 square root of 2. But the issue is x has to be negative because we're in quadrant 2. So it's negative 2 square root of 2. Now I know my x and I know my y, and I can use that to find our sine values. So sine of theta, we know, is 1/3. Cosine of theta is -2 square root of 2 over 3, because it's x over radius. Tangent of theta is 3 over -2 square root of 2. And I have to multiply both sides by a square root of 2. So that gives me 3 square root of 2 over -4. Sorry, tangent's y is 1. So I get square root of 2 over 4 as my answer. Cosecant of theta equals r over 1, which is just 3. Secant of theta equals 1 over 2 square root of 2. That's negative. Multiply both by square root of 2. I again get negative square root of 2 over 4. And last, for cotangent, which is x over y, I have -2 square root of 2 over 1. So I just get -2 square root of 2. So that's how we would find the exact values given one value and the sign of another using the unit circle. You could also use trig identities. So let me clear up some workspace and we'll take a look at trig identities. So using trig identities, we have to look at what we know. Well, we know that sine of theta is 1/3, and I know, using a trig identity, that sine squared of theta plus cosine squared of theta is 1. So if I have 1/3 squared plus cosine squared theta is 1, that gives me 1/9 plus cosine squared theta is 1. So cosine squared theta is 8/9. And take the square root of the whole fraction. That gives me cosine of theta is the square root of 8 over 3, which is square root of 2 square root of 2 over 3, but it has to be negative because cosine is negative. Now I have my cosine and my sine, right? Cosine of theta is -2 square root of 2. And I can use this information to find all of our trig identities. So sine of theta, 1/3. Cosine of theta, -2 square root of 2 over 3. Tangent of theta is sine of theta over cosine theta. So I get 1/3 over -2 square root of 2 over 3, which is 1/3 times 3 over -2 square root of 2. My 3's cancel. I multiply by the square root of 2 on the top and the bottom, and I get negative square root of 2 over 4, just like we did before. Cosecant of theta is 1 over sine of theta, which is 1 over 1/3, which is 3. Secant of theta is 1 over cosine theta, which is 1/3 divided by, which is 1 divided by -2 square root of 2 over 3. That gives me 3 over negative square root of 2 times -2 square root of 2. We multiply top and bottom by the square root of 2. I get -3 square root of 2 over 4. And then cotangent, which is cosine of theta over sine of theta, is -2 square root of 3, -2 square root of 2 over 3 over 1/3. Once we multiplying by 3, so I get -2 square root of 2. You see, we find the exact same values. It depends how you choose to approach it. Whatever way makes you feel the most comfortable. I prefer the unit circle, but that's because me and the unit circle are like best friends. But if you'd like to use the trig identities, go for it.